We welcome now our first speaker, which is actually the second paper in the program, Sveta Matskevich, and she is from University of Haifa.
I'm going to talk about the new conceptual framework for the archaeological data encoded in the Levant. So recording method in the Levantine archaeology, they developed during the end of the 19th and the 20th century as a result of a strong influence of British, German, American, and French archaeologists, and then developed independently. The majority of the recording systems finally formed in the 1970s, and they didn't change conceptually since then. While switching from the paper to computer to digital record and moving from one software version to another, we preserved the core of our recording method. We save for the sake of consistently, but mainly because it works. The high-level archaeology, high-level like the theory, went ahead meanwhile in all kinds of post-processual directions, but the data with which we work kept its tabular structure, which hardly reflects the ideas of post-processualism. In this presentation, I want to suggest a new conceptual framework that can accommodate records from different theoretical backgrounds. First, for the short definition of a recording system. Each recording system consists of three main parts: entities, documents, and the workflow. Entities are terminology which you use in order to formulate the excavation. By documents, I mean all outputs of the recording, and the workflow shows who does what and in which order. The two basic entities of each recording systems are spatial units and finds, so we can note where we dig and what we find. In terms of documentation, we can divide all recording systems into two parts: the structured ones based on forms, and the unstructured based on diaries. Now, spatial units have various names, as we know: loci, context, levels, etc. But the concepts behind all these names can be grouped in three categories. And the differences between them are expressed mainly, first of all, in the relation to the depositional event. So first, we have arbitrary spatial unit called speed, normally, which is used mostly in the prehistoric excavations, but not only. Second, the most common one is depositional unit, which is local, which we call mostly loci, and in Britain is most closely the closest analogy is a single context. And the behavioral unit, which is called locus sometimes feature, which is a combination of several depositional events. If you think about loci of Tel Hatzor or like the old excavation or Tel Dan, this is what I mean. Now the finds, the two basic concepts are a basket, like the old-fashioned basket, which is a group of finds that come from the same context, and the single find that comes from a spatial unit or just a part of it. Now, the documentation, as I said, structured or with the forms or unstructured diaries. Now, in these 4 slides, I defined the recording systems of the Levant without ever mentioning any theoretical background of this excavation. And I claim that there is no connection between the theory, like the theoretical agenda of an excavator, and the recording method we use. And the question is why. So let's remind ourselves that the transition from paper recording to the databases happened in the days of flourishing positivism. Then and then the relational databases were in fashion. So in most of the cases, the tables were built for already existing entities, and the electronic forms mimicked the paper ones. This was indeed a huge step in the development of archaeological data management, but where it stopped. And unfortunately, the post-processual movement did not have such an echo in the world of archaeological data. So if a recording method would be somehow linked to the theoretical agenda of an excavator, we would expect that, like, if you excavate in some evidence of an historical fact, then the record of such excavations is objective and the observation is straightforward, right? And when the recording system, we would imagine, is a tabular one with predefined list of values and codes, and where each attribute has one value only, and there are no question marks. On a relativistic excavation, on the other hand, where we have multiple interpretations and very uncertain conclusions, the recording system would look very differently. But in practice, where recording method reflect only our tradition, or mostly our traditions. And even the most post-processual members of the community are still thinking in tables. So what we suggest here is a new graph-based data structure that could close the gap between the high-level theory and the low-level theory. Graph data structure consists of 3 parts, and that's why it's also called a triple. The 3 parts are subject, object, and the property. Each relation between the 2 items, any 2 items, can be expressed in such a sentence. Unlike tabular data model, in which entities are separated between tables with specific link and linked only in very certain links, in a graph, all data is connected information is actually linked, and therefore can be easily retrieved. Data with a graph structure, legacy data, and present and future excavation systems can be linked without losing their original characteristics. Also, here you see some example of the graph data, and this is the relational database. And here is a graph data cloud, which is beautiful by its own. Now, the idea of using graph for encoding archaeological data is not new at all. For more than a decade, it's used for in various European data projects for collaboration and between institutions and the digital archives, mainly as a tool for mapping for high-level ontologies. So if speaking about legacy data, a case study I can show you is here's excavation site of Tel Dor, which is one of the major tel excavations in the Near East. Here you see in colors various excavation projects conducted during the more than a century. The two data sets I have is like the red one, excavation of the Hebrew University. It started in 1980 and goes till now, and the light purple, which is excavation of Avneraban in the like the maritime excavation and the coastal projects conducted in 1980s. Avneraban's excavation was documented in diaries and some basic basket lists. And the tel excavation was run with forms, pre-printed forms from the very beginning, and then moved to Access database. Now, in order to put these two data sets together, the structure of each system was mapped to the SciDoc CRM ontology, and but keeping in mind that the conceptual meaning of the entities was not the same. Like locus at Raban excavation, at Notel excavation is not the same locus, so I used SCOS, like simple knowledge ontology, to link between the two terminologies, let's say, like what is what. Now, to the present day recording, I will show several specific points in which the graph structure can be much more efficient in recording than a regular table. Now, differentiation between spatial and find, spatial unit and find is not always trivial. Like in this case, we have an olive press, rock cut one, which will be excavated as a spatial unit, drawn on a plan, and inserted in the spatial unit tables, while a build one will be probably recorded as a find and possibly moved to a museum. Now, as you see, it's all a matter of interpretation. What do we call this olive press? And this is exactly the point of this conceptual framework, that actually a recording event is a central one in any recording method. Therefore, it should be like a central point of this of a data structure. Now, if we use a regular table, then we'll have two olive presses in two different tables, and if one wants to find all olive presses of the site, it wouldn't be an easy task. But if we put, if the record is in a graph, then we can define olive press as just a type of installation, when querying such data would be easy when we ask for all olive presses found in as a special unit type or find them in the whole database. Now, another problem of interpretative archaeology is how do we model and record multivocality. What we do on the paper, we just cross a previous opinion and put a new one. But actually, if we use graph, this is not necessary. We can preserve the whole history of the debate, because we can record each recording event with two attributes, timestamp and the actor, and the content of that record. So there is no contradiction between different opinions. And another example is uncertainty. Here you see a locus index. It will be published in the final report. And arguably the most uncertain phase definition of a wall. So how do you put it all in a, I mean, it's not a problem to put all these question marks on the paper, but how do you query database with all that mess? Again, if like in a human language, this expression means like that wall was like have 3 different options of the existence with different levels of uncertainty. So if we add to the value to the value of the record, a property that says possible, probable, or unlike, then again we can record all that and query with the uncertainty qualifier as one of the query attributes. So in conclusion, I want to say that this interpretation-oriented conceptual framework can be used for mapping the data set to upper-level ontologies and thesauri, and to manage data sets that come from different theoretical backgrounds and accommodate various characteristics of post-processual record. And thank you.